Today I want to look at one-to-one functions, and we need to review what we mean by function for that discussion to make sense. So here I have a couple examples. I have f of x equals 2x plus 1 and g of x equals x squared. And if you remember with a function, what we do is we pick a value of x and we replace all the x's in the function with that value, and then we get an output. And it's very commonly drawn like this. I have a domain and a range, and what I do is I pick a value in my domain. So for example, if I pick 1, I plug it in my function, and that maps me over to the range. For example, here when I plug in 1, I end up with 3, right? 2 times 1 plus 1. And so f carried the 1 over to the 3 from the domain to the range. All right, now if we look at x squared, something kind of interesting happens here. If I plug in 1 into this, into g of x, well, 1 squared is just 1. But also notice, if I plug in negative 1, I also get 1, right? Because negative 1 squared is 1. So I got two things that get two inputs that get mapped to the same output. Is that okay for a function? Yes. If you remember, the one thing we can't have for a function is I can't plug in one input and get carried to two outputs. Okay, so that means not a function here. Again, the distinction is I can't plug in one input and get two outputs, but I can plug in two different outputs and get the same input. The analogy I like to use is if I went to a restaurant in this bottom situation, the guy in front of me orders his cheeseburger, and I order the exact same cheeseburger, and they charge us two different prices. Okay, that's a problem, and so that's an example where we don't have a function. But I could order or ask about the price of two different items, and they end up being the same price, and that's not a problem at all. Okay, so that still fits the function. Now we want to look at something called one-to-one functions. And so here's how we define a one-to-one function. We say a function is one-to-one if for every distinct elements x1 and x2 in the domain, so that means two different things for my domain, would they get mapped to different outputs. So f of x1 does not equal f of x2. So again, okay, so we say a function is one-to-one if you take two inputs, x1 and x2, and they're not equal. x1 does not equal x2. If x1 does not equal x2, then f of x1 does not equal f of x2. So in other words, if you have different inputs, they get mapped to different outputs. Okay, so different inputs get mapped to different outputs. Okay, so if I look at the pictures I just drew, let's figure out which one of these are one-to-one. Well, we know the bottom one's not even a function, so that doesn't even count. The top one, if you think this is linear, if I plug in any input, I can only get one output. So this guy is one-to-one. But for g of x equals x squared, I show that you can pick two different inputs and get the exact same output, which directly violates what we mean by one-to-one. We want to be able to plug in one input and get exactly one output, and we want every output to come from exactly one input. We want it to be that if we pick two different inputs, we get mapped to two different outputs, and that's the key definition of one-to-one functions. All right, now we can look at this with a graph through what we call the horizontal line test. Okay, so here I have an example where it says to use the horizontal line test to see if the following are one-to-one. Now, what is the horizontal line test? The horizontal line test says if I take my graph and I draw a horizontal line and it crosses the graph more than one time, then that's not a one-to-one function. And think about why that would be. So let's jump to part C, because I can see if I draw a horizontal line straight across there, I've actually hit this graph a lot. Okay, so that means this is not one-to-one by the horizontal line test. But why would that be? Because here I have different x values. These are all the x values that all give me the same y value. If I have different inputs that give me the same output, it's not one-to-one. And that's how we see it, and that's why the horizontal line test works. Okay, so now if we look at part A, x plus 1 cubed, we can graph that because we know from our transformation formula, this looks like x cubed, but I've been shifted to the left 1 unit. Okay, so where I was at the origin here, I'm now at 1, and x cubed looks something like this. Okay, and you can see here, if I draw a horizontal line, doesn't matter how I draw it, I'm only going to cross my graph one time. Okay, so this guy is 1-2-1. All right, now for part B, we've already talked about g of x equals x squared, but just for illustration, let's draw the parabola. We know it's a parabola. And I can draw a horizontal line where I've crossed the graph more than once. Okay, so that means I have two different inputs. For example, -2 and 2, and they have the same height, the same output at 4. Okay, so this guy is not one-to-one. So you may be asking, why do we even care about one-to-one functions? And the answer to that is with inverse functions. I'm going to show you what that means in the next video. I hope this makes sense. If you have any questions on this, please let me know, and thanks for watching.